lecture series of basic electrical engineering. Today we are going to see the fifth module. In this module name is measurement and instrumentation. In this we are going to see about the topic that is single phase and three phase watt meters. So what is a watt meter? So here you can see this is the watt meter. Watt meter is generally used to measure power. That is the unit of power is watts. So in turn we are using a watt meter to measure the power. So this is the physical appearance of the analog watt meter which you are seeing. I think you might have used this in the lab also for measuring the power. For example, load test on transformers, I think you might have used it, and measurement of three phase power also you have used this watt meter. So what is inside the watt meter? So inside the watt meter, we are having two coils. One is the current coil, other one is the pressure coil. So this is the current coil and this is the pressure coil. Here, the current coil is always connected in series where we are going to measure the current, and the pressure coil is always connected in parallel in addition with one resistance that is known as the shunt resistance, that is known as the pressure coil. So why current coil and pressure coil? We know the formula of the power, P is equal to V into I. In case of AC power, VI cos phi. Okay. For producing that power, we need both voltage and current and power factor. So we are making the use of two coils. One is the current coil and pressure coil. So we know already the current coil or current measurement can be done only when it is connected in series. And similarly, the pressure or the voltage can be measured when it is connected in parallel. So here one more point to be noted is the current coil has less number of turns and it is thick in nature, that is area is more, whereas the pressure coil is thin, number of turns will be more, okay, to measure the voltage. So this is actual circuit of a watt meter. So this will be inside the watt meter. So now we are going to see about the dynamo meter type watt meter. So why it is dynamo meter type? Uh, we know the dynamo principle. Similar to that, it will be that is a coil will be moving inside. So that principle is known as dynamo meter type principle. So here it essentially consists of two coils. One is a fixed coil, other one is the moving coil. The fixed coil is connected in series with the load and it carries the circuit current. So we already discussed about it. So that's why it is known as a current coil. The moving coil is pivoted. So we saw one parallel here. You can see one parallel winding is there. That is the pressure coil. Uh, it is pivoted. That is the it will be moving inside the fixed coil. Okay. So which is mounted in a spindle where moving arrangement will be there. Okay. So this diagrams proves that. Oh, here you can see the current coil which is connected in series across the load, and this is the moving coil. It is connected across parallelly to the load. Here this moving coil or voltage coil is fixed in a pivot. That pivot is in turn connected to the pointer. The pointer is moving on the scale where power can be measured. So here there may be some supports also, along with that spring control is also there to provide the controlling torque. So when we give the current here, the deflecting torque will be produced and a spring will be connected fixed at one end and other end is movable, that is connected against the against the pointer movement. That is the spring control have been applied. So here you can see little bit clear in this diagram. So here you can see that is the leads of the current coil. So it is connected in series, and this is the leads of the potential coil. So it is connected in parallel, whereas here you can see the spring control spring, so which produces the controlling torque in which the pointer move against the spring pressure and it produces the uh, torque, controlling torque over here. So this is about the construction. So as we seen already, we have two types of coils, fixed and moving. The fixed coil is once again split into two equal parts. That is, in the previous diagram you can see here there are two coils Here you can see two sets it is splitted. So why it is splitted? So because to produce the deflection, to produce a magnetic force, and two coils are air cored. So there is no separate cores for this. Maybe in motors and all, you may be using silicon core or soft iron core, but here it is air core to avoid the hysteresis effect which used on AC. So hysteresis we know already, it is nothing but the magnetic cycle in a magnetic material. So we are using such air cored coils. The fixed coil is always connected in series with the load which carries the circuit current. So that's why it is known as the current coil. And the moving coil is pivoted between the two parts of the fixed coil and it is mounted. As we told in the name itself, it's a moving coil. So it is fixed in a moving assembly which it is connected of the spindle. The pointer is attached to the spindle which gives the deflection. The moving coil is always connected in parallel with the load and carries the current proportional to the voltage. So we know as per the Ohm's law. So I think in later slides we will discuss that. That's why it is known as the potential coil. A high resistance is connected in series with a moving coil to limit the current through it. So as per Ohm's law, so what is V? I into R. Okay, so the current is flowing with high resistance. In proportion, we are measuring the voltage in it. So this is the principle behind it, why we are using the high resistance in the moving coil. By limiting the current, the moving coil is uh, made of lightweight in turn for the sensitivity of the instrument. So as we discussed in the earlier classes, sensitivity is very important for an instrument to get the repeatability of the readings. And also here we discussed there is a controlling torque which is provided by the control springs. Also it serves for the purpose of producing the leading current in and out of the moving coil. So it is depending upon the what we say cos phi. Okay, and air friction damping is employed in this instrument. So we know there are many types of damping: oil, air friction damping, oil friction damping, eddy current damping. Here we are going to use the air friction damping. In this instruments, the operating field. So how it is works? So in this instruments, the operating field is produced by the fixed coil, similar to the permanent magnet in a dynamo, and it is electrodynamic. That's why we discussed in the first slide only. It is working on the principle of dynamo. That is, one magnet will be there, in between coil will be there. Similarly, instead of magnet, we are replacing it with the fixed coil, and it is usually employed in the AC power circuits. And so it is similar to the principle of a motor. We can tell whenever a current carrying conductor is placed in a magnetic field, the conductor tends to produce a force. So similar to that, whenever a current carrying coil is placed in a magnetic field, it produces the uh, force. That is, in other terms, it can be known as a deflection. The field produced by the current coil uh, moving sorry, when the field produced by the current uh, by moving coil tries to come in line with the field produced by the current carrying by the fixed coil, so a deflecting torque is produced. So it tries to align itself in the magnetic lines of force, so it the resultant will be the deflection. So here you can see the principle, working principle here. Here we know that the fixed coil, this is the moving coil. When the power supply is given to it, it produces the flux here. You can see in the both the directions. This is the towards the observer, this is the away from the observer. And here one more current which produces another flux in the coil. So which tries to tend to move in one direction. So here you can see this flux is upward and downward due to the current direction, and the force is also similar to that, and the current direction due to both interaction. Here you can see the pointer tends to move in this direction to align itself. So there will be a resultant, we know already. So it produces the resultant force in the form of deflection. So when the power is measured in a circuit, the wattmeter is connected in the circuit. This is the third time we are discussing, that is the current coil is connected in series with the load and carries the current, and potential coil is connected in parallel with the load, carries the proportional voltage. So the what we thought there. So there are two producers, two forces will be produced, Fm and Fr. So Fr tries to come in line with the Fm, that is the main field flux, so that we will get a deflecting torque and the moving of the coil, and the pointer deflects to the voltage and current values proportionally. Okay, the net torque produced will be VI cos phi. So, and it is controlled by the controlling torque, which is produced by the deflection springs. So, what are all the advantages? So, it can be used in both AC and DC circuits. It has a uniform scale, and it has a high degree of accuracy, can be obtained by careful design. What are the drawbacks? The drawbacks is nothing but it is very sensitive to the power factors, and it causes errors in low power factors. The reading of the instrument may be affected by stray magnetic field acting on the moving coil. Suppose a magnetic instrument is nearby, you will get a error reading in it. In order to prevent it, magnetic shielding is provided in the enclosing instrument. That is, we will keep it in. If you see the old type of wattmeters, it will be in a wooden box in order to avoid the stray magnetic field. So like that we can avoid that. So we will have a recap by seeing this one. So here you can see the electrodynamometer type wattmeter. So here you can see the picture of it. So as usual, it construction has one fixed coil and moving coil, pointer and a measuring scale will be there. So the fixed coil has two sections and used to provide the required magnetic field. So it is connected in series with the load, and similarly one more coil is the it is also known as the current coil. Fixed coil is also known as the current coil. The moving coil has fine wire, that is less thin thickness, and it has many number of turns, and along with it, it is connected across the supply with a series resistance. This can be also known as pressure coil or voltage coil. Both the names are apt to it. So the high resistance is connected to measure the current proportion voltage. So also it provides for the limiting the current in the moving coil. That's why we are using this resistance. The moving coil is mounted on the shaft, which we name it as a spindle, and it is attached to a jewel bearing. So this is the moving principle. Here you can see the coil rotates when the flux is given. The pointer is small needle connected to the movable coil. It is less in weight. The needle moves over the measuring scale. So now we are going to see the working of it, how it will work. So here you can see that when the power supply is given, what is the impact? Here you can see both the coil get the supply. So the both the coils, in fixed coil the current is passed, the moving coil the voltage is passed. Due to this we can get an interaction between the two. So the flexible magnetic 1 and 2. So always the magnetic field produced by the fixed coil is directly proportional to the load current. Similarly, magnetic field produced by the moving coil is directly proportional to the voltage. So due to this interaction, the two magnetic field, the deflecting torque is produced on the moving coil, because the fixed coil doesn't move, so it is fixed stationary. So that what will happen, the moving coil tries to align itself in the magnetic lines of force which is attached to the pointer. The pointer will be moving over the scale where power can be measured using the measuring scale. So the deflection torque or deflection is directly proportional to the total power applied to the load. So this is about the construction and working of a dynamometer type wattmeter. So next we are going to see about the three-phase power measurement. I think in module 3 we might have learned about this clearly. Once again we are going to have a recap and we are going to see the instrument. The three-phase power measurement, it is very essential for power generation, transmission and distribution. In the polyphase system, it is common method used uh, for measuring the power transfer. Uh, Generally, we will be using the polyphase and distribution lines also, and electrical grid also. So here you can see three-phase power measurement. It is actually a digital type meter. So it is a multi-type, multiple type of meter. So here you can see the power can be measured in a three methods, that is 3 watt meter method, 2 watt meter method, and single watt meter method, which is the apt one that also we are going to conclude. So measurement of power by using a 3 watt meter method. So here generally we have the power of three-phase four-wire system. The three-phase, the three maybe in delta connection there will be three-phase three-wire system. So both balanced and unbalanced load we can measure. So here you can see in star and delta we are using a 3 watt meters, W1, W2 and W3. And if it is a star connection, neutral point is connected commonly. If it's a delta connection, it is not connected in a neutral point. Instead it is connected to the one more phase. So here 2 watt meters are used. Two single phase watt meters are used for this purpose. So this method, we will get the total power of P is equal to W1 plus W2 plus W3. That is the summation of total powers. But I'm not sure this method will be apt for all the things. So we are going for a two measurement of three-phase power by using 2 watt meter method. 2 watt meter method can be used either in star and delta, both the types we can use for measuring. So it can be irrespective of the load also, maybe balanced load or unbalanced load. So here you are seeing the star connection. I think we might have derived an equation for this also in the module 3. We have 2 watt meters, W1 and W2. So it is connected in star. So here you can see the detailed connection. So this is the actual construction of the three-phase watt meters. So the connection will be like this. Inside we will be having two elements. So two element is nothing but element one with a fixed coils which is connected in parallel, and one moving element, that is the shunt coil, or I will name it as a pressure coil. This is one assembly. So this is the second. By these two elements, we can measure the three-phase power. That is possible. It is universally adopted for this also. It is a very good method of measuring the power also. So the same single-phase wattmeter with two element is connected. That is the only one difference we are going to see in it. So the connection we are going to give in the similar way. How the picture is given, you can see the current coil connected in series with one phase. Here one more element 2. Here also you can see one is connected with the current coil, and the other pressure coil is short circuited by means of the resistance R. So and one more adjacent resistance is connected in order to match the resistance in the circuit. So this is the easiest method to measure the power. So this is the one more thing. Same 2 watt meters are used in it. So here you can see the deflection in a single meter by means of 2 watt meters. So here the connected loads observe the power. That power is measured using the 2 watt meters. The average power can be drawn by the load is read in the watt meter. So this is the system. So here you can see measurement of power by single watt meter method. This maybe or may not be apt method because here you are using one element as a current coil, other element as a pressure coil, but it is connected to single phase. So we can come to a conclusion that is 3 into power per phase. That is W1 watt meter reading into 3 gives the values of all the phases. So I think this may not be an apt method, but somewhere it will be used like measuring of balanced load of resistances. Resistive load, we can use this, but there should be uniform distribution of the power. That is a balanced load. Okay, thank you for watching.